All right, let's go ahead and get started. We got a lot of information to cover here. I appreciate everybody showing up. Hope everybody have a good new year and starting off 2024 on the right foot. So let's get started with this. I had a lot of questions that came in about some spray foam towards the tail end of the year, so I thought I'd do a video webinar on this and go through some stuff that I've experienced through my years of practice and inspection, so we can go through this. But as always, thanks for joining us. Today's webinar is being recorded. It will be uploaded to our YouTube channel, which you can find by searching Spear on YouTube, SPEER, or you can go to our website directly at eepartnership.org, and under the news section, you'll find our resources page. And once you're on the resource page, you can find a link to our channel. There are a lot of other previously recorded webinars on there that could be some useful tools for you. Within 72 hours of today's presentation, you'll receive a course evaluation email from Kathy Lawrence. Please complete the survey. When you send it back to her, she'll give you a course completion certificate, which contains the course title and ID number that you'll need when reporting your CEUs to ICC. Lastly, as always, we have the chat feature is open. If you have any technical difficulties, put them in the chat. We've got Q&A features open as well. Post any questions you might have, and I'll try to go through them as we are going through the presentation. So today we're going to talk about spray foam insulation, and when is it installed correctly, and then how to inspect for code compliance. As always, though, just some housekeeping if you're new to our channel. So Spear, basically, we're a nonprofit. So we are one of 6 RIOs. So it's a Regional Energy Efficiency Organization. Hold on one second. We've got somebody with their hand raised. Let me see. Yeah, I've unmuted you. Go ahead. Did not come through. If you want to put your question in the chat or in the Q&A section, we can try to answer that as we go through that. So what we do is we offer training, in-person field training, as well as me doing the webinars, and like what we're doing here. So we offer, I can also do a one-on-one IECC test prep training for anybody looking to get certified with IECC. So I'm open to answer any questions about energy code related, ASHRAE 90.1. We can go through that. We do a lot of communication with building officials, third-party energy inspectors, and when cities adopt the 2021, it's always good to try to talk and have some different opinions on how cities are adopting or amending the code and how they're enforcing it in the field. So we still work with cities to help with their adoption process. And work through any questions they might have to help navigate the energy code and make it a little bit less of an impact to the builders as they're trying to adopt to the new code. So on the agenda we have for today, so we've got purpose of insulation, meeting building codes and standards, identifying the thermal envelope, what is spray foam. We're just going to go through a brief part of that. What are the benefits for that? Then we'll get into that residential application, some on-the-job training. I got a video where I'll walk the house and we'll talk about that and narrate through it. And then inspecting spray foam insulation, then other items to consider as well. But please keep in mind that a lot of the stuff I talk about comes from my understanding of the intent of the code and my personal opinion from 10 years plus of energy inspection experience. Not everything I mention can be found in black and white in the text of the code book. My hope with this webinar is that you walk away with a little bit more information, better understanding on how to ensure you're fully inspecting foam insulation for compliance and not just for coverage. In other words, does it look correct? Maybe, but is it correct? So knowing how you're looking at it from a compliance standpoint. Lastly, I'm not against using foam one way or the other. I believe that to meet the intent of code, you inspect all insulation materials with the same measuring stick. That will make a lot more sense later as we go through this. It's really just another insulation product that traps air, resists heat transfer, but it has the power to do 2 things at once. It can insulate, it can air seal, which could potentially reduce construction costs by doing a time savings on site. So that's kind of what it's there for. So purpose of insulation, or as I like to call it, what's the intent of insulation? So as everything goes, the understanding of the intent is how to verify compliance. So insulation in houses serve several important purposes or intents. It's temperature control, it's energy efficiency, it's soundproofing, it's moisture control, and then of course the lesser environmental impact. A lot of people see that as a green product. It's less of an environmental impact. But by providing these benefits, insulation has a critical component of modern home construction and renovation, contributing to overall comfort and durability of the living space and the home. But to us and in our world, insulation serves two main purposes or intents. First, it resists heat transfer into the home to maintain comfort with the home and reduce energy consumption for conditioning. And second, for compliance to the energy code. So I'll probably mention this several times through the presentation, but it's not just about having the material installed, it's how well is the insulation installed, be it bats or foam or other. So for compliance to the energy code, though, we must meet the R value requirement for your climate zone. If a builder is using prescriptive, then we've talked about this in several webinars. It's the R values from the table that's in the code book. I have that listed here, showing each component. None of these components can be traded off. It's just strictly a recipe out of the book. This is how it needs to be handled. This is what you need to inspect. But once the UA alternative or whole building performance or any above code program like Energy Star is used, then the R value requirement of the thermal envelope can change. And then it doesn't have to meet what's in this table. It can vary because it's being used as a trade-off. In Texas, we usually find builders using higher performing windows, more attic insulation. And what they're trying to do is lose the continuous insulation requirement. So that 13 plus 5 or the other in climate zone 3 or higher, trying to lose that outside continuous insulation, not having to do that. So when that happens, though, it's even more difficult and more important to verify the correct R values being achieved with only cavity insulation. In other words, having poor installation resulting in a grade 2 or a grade 3, which we'll talk more about what that is later. It's lowering the overall effective R value, reducing thermal resistance of heat transfer, and in turn, it's increasing the energy used to maintain the internal comfort. In a simpler term, it's a crappy install. It's less comfortable for the homeowner, causing them to change the thermostat. And when the thermostat's changed, it increases the energy used for conditioning. That's kind of why we have that here. That's why we're doing the insulation. That's why we're trying to do is resist the heat transfer, trying to keep the house at a more comfortable level longer. That's also why we do air sealing as well. But ultimately, it's about achieved R values. This is a table I think I pulled off of Owens Corning. I'm not exactly sure, but all insulation has a manufacturer listed R value, but only if it's installed per the manufacturer's instructions. So depending on what product's being used, you can go to their website and look at the instructions on how to install it. It'll tell you in a distinct and specific recommendation on how you're to install this product to achieve the R values that they've now listed and deemed as that product will perform as. But anything less than what they're recommending on how it's installed lessens the performing R value of the wall. So just because a bat has an R13 on it doesn't mean that its installation R value performance is that. It depends on how well it's installed. Same goes for foam, same goes for other insulation materials. So keep in mind as we talk about earlier, what we talked about earlier, if the R13 is needed for compliance and open cell foam has an R value per inch of 3.6 to 3.8, as what we can see kind of here in this chart, then it basically, you can do that, accumulate that math and say, well, if it's a 2x4 cavity and it's at the top most 3.8, what is the R value that we're getting in a 3.5-inch cavity? So if it averages less than anything of a 3.5 in that cavity insulation, it's not really doing an R13. We have a question in chat. I was forwarded this link by my supervisor. I was not registered for the class. Yes, yes. Thanks, Michael, for that question. He's basically saying he wasn't registered for this, but will I get credit for the training? Absolutely. Since you're on the webinar, Kathy will have your email address. She will send you a course completion survey that you'll need to fill out. And once you do that, you'll get your IECC certification for course completion. Great question. I appreciate that. But even if the highest R value per inch is 3.8 and it's perfect with no gaps and fully fills the cavity, the achieved R value is about a 13.3. So keep that in mind as we go forward and we start looking at pictures of what we're looking at on-site inspections. We've seen this before. It's the example of what ResNet has put together for grade 1, grade 2, grade 3, and what does each one of those mean. So I know we've talked about it before, but using what we've learned from R value of the material, now let's talk about grading how well it's installed. These illustrations make it easier to identify, but it's much harder to do in the field than just looking at these pictures. Once you have a house that you're looking at, everything starts to blur and look the same. So you have to look at each component and try to grade each one of those. So grading the insulation level effectively lowers its R value. So a grade 2 on a 13 cavity is basically an R10. A 19 reduces to an R17. This is what's put into the energy model on the energy report. So ResCheck and others show a 13 is needed to pass the energy model. Then the model is assumed that the achieved and overall effective R value of 13, not 10, is being used in the model unless it's otherwise stated. I know RemRate and Ecotrope both have listings in there. If you look at their report, it will say R13 grade 1, R13 grade 2. I don't believe ResCheck has that. So when you put that in there, it may or may not show that on the report. If it doesn't say anything, then it's to be assumed that it's a grade 1. So take a mental picture of the one in the middle, and then let's use that to compare what we see in the presentation going forward. My mental picture will be a screenshot. So I'll have a screenshot that I can pull up and show as we go through pictures, and you can just look at it from what it compares to and how we're looking at the foam. So real quick, what is spray foam? We've talked about there's several materials that can be used for insulation. The R value per inch is what's important. And then you determine the thickness that's needed to reach that required R value per the climate zone. So the highest R value per inch, a lesser amount of material can be used. So if you have a closed cell and it's 6 on the per inch, then you don't have to use a full fill cavity. But if it's the open cell and you're looking at 3.8 and it's 3.5 inch cavity, fully filling that is what you're looking for. So what is spray foam anyways? It's just basically it's a product that's, and I will talk about more what products are in it. It's a product that's it's two liquid components that actually are, when it expands, it creates bubbles, and when the bubbles are created, then they form a resistance to heat transfer. Just like trapping air in batt and fiberglass material, you're trapping air pockets within the expandable foam. It's slowing down the heat transfer. As the liquids mix, they react, they expand rapidly, they fill the stud cavity and other areas with the foam. Makes it easy to get in those little corners, those crevices. So the foam hardens and cures over several hours. So a lot of it is you can hit air sealing and insulation with the same impact and the same material that you're using at the same time. That's where we said earlier, where you can save some time and costs and some of the cost of construction if you could do it quicker. The two main type we see, of course, is open cell and closed cell foam. Sorry about that. Jumped ahead a little bit too fast. So what is spray foam? I'm not sure why that picture is not showing up, but what is spray foam? There's isocyanate, there's polyol resins, there's blowing agents, there's catalysts and other materials that are listed in there. So this is the stuff that they have to mix with that material and use that to expand the foam. And so we'll talk about kind of a brief history of it as we go through it, but there's different materials and components that add to it. You see if this works. Whoops. Sorry, I have a slide that has a video on it that is not playing. So a brief history about spray foam we have here. It's been around since the 40s. It grew in popularity due to the avoidance of asbestos materials or materials that had asbestos in it or was subject to possible asbestos in it. We've talked about that before in some of our other videos. Polyurethane was used by the military in the 40s, usually and through the airplanes. And then basically something called a blendometer was invented in 1953. And it actually mixes the chemicals on site. So that's a product that's used for that. This is kind of a picture of I guess a new modern version of a blendometer. It has the two drums of the components that get mixed in the center with that master pack. And then it has the blowing agents that are in it and the electric pump that actually will put that into the wall. And then of course we just watch that expand and it fills it up. So types of spray foam, open cell, closed cell. We talked about that earlier. Open cell is that soft and flexible stuff that's in the walls. Bubbles are broken when they're there, but it actually has an air gap that's through it. So it actually is a spongy texture. It's really soft. Closed cell foams are more rigid. They're more dense. Each bubble cell remains intact, makes it more stable. provides a higher strength and insulation R value. Trying to push on it is harder to do if it's closed cell. Open cell will actually just give and collapse. So the most common type that we see in the field, or what I saw during my inspections, was open cell isonine products. So they make different types of isonine, one being the LDC 50, which is petroleum based. The other is LDR 50, which is castor oil based, which replaces the petroleum and considered more of an eco-friendly, since the castor oil plants do not require water or pesticides to grow. Then there's also an MDR 200, which is a greener version that contains up to 12.6% recycled plastics. FEMA, and John puts in here, FEMA building number 2 requires closed cell insulation for crawl space subfloors. That is probably true. Yeah, FEMA has some different requirements on what's needed for that part of it. That's a great point. Properties of open cell and closed cell. We talked about it briefly earlier, but the open cell has a 3.6 to 3.8 per inch. Closed cell is 6 to 7 per inch. Keep that in mind as we go forward. Air barrier. Open cell acts as a good air barrier, but it is not a vapor barrier. It does not act very well to slow down moisture transfer through the walls. Closed cell acts more of an air and vapor barrier, and a water barrier as well. So it can add 3 different layers of protection in the building as if you use closed cell. Most people don't use closed cell in the humid climates in Texas for residential. As John mentioned, some of the FEMA bulletin is requiring, the number 2 bulletin is requiring closed cell to be done in the crawl space. There are probably different areas. That's for moisture mitigation from the walls that are under the underground, built below grade, because you've got a lot of moisture that comes through there. There's a lot of problems with that if anybody's used to basements and seeing how basement work. So benefits of foam, we got energy efficiency. We talked about that, air sealing capabilities, moisture control, longevity, and then of course sound reduction as well. But why would a builder want to go, John put on here just to clarify, in the floodplain? Yeah, that's a great point. But why would a builder have, one way or the other? There's a lot of times some of the builders are using this as a marketing tool to differentiate themselves from having a newer, innovative product that has more sound deadening. There's a lot of builders that choose to use it if you're around an airport or a busy highway. It reduces the interior sound quality of the home, but major advantages of doing that, yeah, moisture deterrent. The rot and bacteria are common in moisture presence with the building. The spray foam can help resist some of that. And then you got no temperature fluctuations. They basically say if the house is done correctly, the attic and the house itself will be about 3 degrees difference in temperature. Humidity is a different thing, but the temperature itself is about 3 degrees different. Overall improved comfort, of course, air quality improvement. So since you've got less holes and cracks in the building, you have more of a chance to clean the air on the inside and actually hold a longer air quality that's better inside the home. Ease of installation, we talked about that earlier, is that you cut out 2 birds, 1 stone. You're actually air sealing and you're insulating at the same time. It's ease. It doesn't have a lot of people on site. One person can be doing the foam, and while one person runs the truck, it has less people on site to do that. Noise reduction, we talked about that. And then eco-friendly as well. So it's greener for the earth. We'll use that for more eco-friendly, consumes less energy, and ends up having a lesser carbon footprint as well. So we talked about some of that already, but builders, sometimes if they're asked by the insulators, what would you want to do? There's some benefits that are listed in here, and then the builder makes the decision of either by cost or by where the building is located or how they're wanting to market themselves to be more energy efficient. So superior energy efficiency, durability, sound deadening, versatility of application, and environmental concerns, and basically improves the overall comfort. So if you're in the market looking for a house and you have several builders to choose from, and you find one that is doing foam over the other, that may be something that's important to you on what you're looking for to try to make the house more comfortable and not have issues with sound from whatever's surrounding the community. However, I pulled this off of one of the builders' website. Advertising benefits sometimes can be misleading a little bit. This is the list of benefits on a website from a mid-sized home builder. So it's unclear as to whether they actually know this is incorrect. It doesn't say, it's not saying per inch, but at the bottom I highlighted, it says the highest ranking resistance value on the market, R6. I know for a fact this builder uses open cell foam, which at the highest is 3.8. So listing it as 3.6 is incorrect. So, sometimes those things can be misleading on what they're trying to show. They're trying to show the benefits. All the other benefits make sense, but looking at what they shouldn't have had the R6 in parentheses. They just said one of the highest ranking resistance value on the market, which is true when it comes to, just spray foam in particular, either open cell or closed cell. It has some of the highest resistance value on the market compared to other insulation materials. But when we get to the inspection part of it, the biggest thing, and we've talked about this before in the past, the biggest thing to look for and to identify is the thermal envelope. This is one of the harder things I had to do to try to teach my guys in the field, was to identify the thermal envelope. There's a question here, two of them, a couple of them actually. Hold on, let me answer these questions. Is there a minimum depth of open cell to qualify as an air barrier? Great question, Scott. I think the manufacturer lists anything beyond 2 inches, it becomes an air barrier. Anything less than that, not so much. Can I speak to the VOCs? That's Garrett. I wish I could do that. That's probably a lot bigger in depth for the webinar that we're on. What I was really particularly trying to hit with the focus of this is to have people look at how they inspect the foam in the field when you're doing a pre-drywall inspection. So yes, it's a long, lengthy, there's a whole lot of different information. There's a lot of misinformation, but there's also a lot of good information depending on the VOCs that are caused by spray foam and the indoor air quality part of that. One part you'll read says it's a better indoor air quality. Others say that there's still a question as to how the off-gassing, how long it lasts, what the off-gassing properties are. So Garrett, I agree with you, but I did not include that in today's webinar. I appreciate it. Cody's actually put actual blown in fiberglass gives you the highest per inch other than closed cell foam. Great point, Cody. 2x4 is R15 and 2x6 is R24, as open cell is 13 and 19. Yeah, I forgot about the high density part of that, but you're right. Fiberglass has a higher density value if they use that higher density bats that can be R15 in a 2x4 wall. Great point, Cody. I appreciate that. But we're back to this. Just important, and the most important, in my opinion, is identifying where the envelopes start and stop. So looking at that and seeing the makeup of how this actually works, and trying to find the continuous alignment all the way around the house. But as we see with this house, it is, I'll try to use a laser pointer. As you see the blue line here, we're identifying the envelope. This is not an encapsulated house. This is a vented attic home. But as you see my pointer going around, you're identifying where the envelope starts and stops. And that to me is some of the most difficult ways of training new inspectors, because it's not as clear cut as this picture leads you to believe. And we'll see pictures of that in the next slide. It becomes questionable when you see an encapsulated house and you're looking at an encapsulated attic, and where does that start and stop? And how is the builder actually handling that to go through there? And you can kind of see it in this. I've had this photo in other videos before, other webinars that we did. But when foam's being used, ensuring there are no breaks in the thermal envelope becomes more important for comfort, energy consumption, and humidity buildup inside the attic. So breaks or holes in the thermal envelope of the encapsulated house leads to large temperature variances, hot and cold spots, an increase in humidity inside the conditioned space, and most importantly, humidity buildup inside the attic. So humidity will rise, as it always does with warmer air, and it will accumulate in the attic. If you have open areas, which this photo is showing on the left, it's the interior wall looking out over a patio. You see the demising wall or the divider wall that's there, or the exterior wall. There's a missing section of insulation. And then on the right is me standing in the attic that's over the house, but I'm looking at the attic over the garage. There is a demising wall built at the very back. However, they've pushed it forward and enclosed part of the service decking over the unconditioned garage into the envelope to put the stairs into the envelope. And now there's a misalignment of the thermal envelope, which we'll see on the next picture. This is looking at the same thing from underneath. is you're looking at, there's the demising wall or divider wall in the attic that's on the left. It stops. There is not any insulation underneath the other, which if you see the pointer, there is going to be an open band joist here, and it's a single story. I understand when I say band joist, that's most of the time, that's a divider between first and second floor. But when you have an enclosed or encapsulated attic, that technically is a second floor of a conditioned space. So you need to have a divider there. But if it's between conditioned and unconditioned, it's all the same. But this flooring and this service decking that's under here, all the way to that garage wall to the right, all of that needs to be insulated. So a good rule of thumb is that you should not be able to stand in an unconditioned area and look up into an encapsulated attic. It should be blocked off. It should be insulated. It should all be encapsulated. In this case, it's not encapsulated completely because the whole floor underneath is missing insulation. I understand they're going to have something to spray against. They only OSB'd it to a certain point. They need to fully extend the OSB all the way out and then foam the underfloor of that, because you're trying to extend the encapsulated attic over an unconditioned garage. So the envelope needs to extend, including the not really a floor, but it's the service decking floor over the garage needs to be extended. So on the residential applications, this is just a quick little short video. They spray the open cell foam. It expands. A lot of times it will expand beyond the stud facing itself. Once you do that, then they have a machine. They can use this machine and they actually shave off the front face of the studs, which basically means now you fully filled the cavity. You fully filled it because you're shaving off the excess. It doesn't really matter if the studs are exposed because you're going to put sheetrock on it. It is a thermal bridge, but in this case, if you're doing an R13 in a 2x4 cavity, you're going to expose most of that stud, so you can put sheetrock against it. But what you're trying to do is you're shaving it to get to the desired thickness of the R value that's required for the climate zone that you're in. And as you see here slowly, you'll see some of the foam is being pulled out of the cavity. It's putting little divots in there. But for the most part, it is fully filling that cavity. The next way to do it is you've got some, it's almost like a reciprocating saw that's really long. As we see here on the left, it's fully filled. They're shaving it to the desired R value. This is going to be a cathedral and or vault ceiling that's actually enclosed with sheetrock. That's a 2x6 that's there. So they've sprayed that through it. And then once they've sprayed that, fully filled it, you're looking at about an R19 cavity insulation, which is what usually is required in the vault areas. So now it's time for some on-the-job training. I've got a video that comes up next. It's 10 minutes long. I'll narrate as I go through it. A few times I'll actually stop and actually discuss what I'm looking at. It's a little shaky. I had some technical difficulties towards the end with that, but I tried not to cut it and splice it. It just runs all the way through. So let's put our VR glasses on, do a pre-drywall inspection of a house using foam. This is a house that's certifying as Energy Star 3.1. So there are things that I may point out that are specific to 3.1, and then the rest of that will all be code. So while we go through the inspection, we'll talk about that. Most of what you see here will still be code only. So this is where we're going to start. Like I said, I'll stop a few times. There's no sound to this, but just approaching the house, walking into the home, verifying, yes, this house is foam. They've used open cell foam. And so I'll slow down as soon as I get to the wall. I know sometimes it's a little shaky, but depending on what you're using. What we're looking at, it's open cell foam. Keep in mind that middle number 2 of grading number 2 insulation. Now look at it from this point of view. And if I stop that here and actually bring that up, I just want to do that just to say, hey, what does that look like? So again, I'm not trying to determine whether or not this is a pass or fail. I'm just describing to you what it is when you look at the foam and how you're inspecting it when it's compared to fiberglass. And I understand what I'm looking at here for resonance defining of grade 1, grade 2, grade 3. It's not telling you that this is batt insulation or fiberglass. It says with fiberglass materials, you're looking for minimal gaps or voids of the insulation, even the front voids. So wherever the insulation doesn't fully fill, that's a gap. So if you look at this, you need to remember, determine that, is that grade 2 or is that a grade 1? So a lot of people will put foam as a grade 1 automatically just because they see foam, and I don't think that that's what needs to be done. So we're going to keep walking through this. Looking up, making sure it's fully encapsulated, identifying where the envelope starts and stops. Looking at how the roof line comes in at the top. There's a vaults kind of there behind it. Still looking at the insulation levels. The shelf over the window output, jutting outwards. For Energy Star and now for code, I'm going to also verify that these headers are insulated. So you'll see me turn the camera and look up inside some of those pockets as I go through this as well. But just verifying, what am I looking at? You know, it's open cell. I can tell they've basically fully filled the cavity. This house was red tagged at one point. I don't know if you saw that earlier, but there was a red tag still sitting on there. And the reason it was red tagged is because it does not meet some Energy Star requirement. You'll see a little bit of darker areas where they sprayed it. I touched on that. It looked like they used a different material, something that was more of a closed cell instead of open cell. But we'll continue on. You can still see the pockets. There's some gaps and some separation at the studs at the top and along the sides. The ones above the top plate, that doesn't really matter, but we're looking at what we're looking at inside the cavity is what we're being concerned with. Mostly fully filled. There are some gaps in it. But remember, keep in mind, I'm trying to grade this. Is it a grade 1? Is it a grade 2? If it's Energy Star, it has to be a grade 1 unless they're using continuous insulation outside, which they are not. So all of this needs to be fully filled and at a level of a grade 1. Still, there's a lot of pockets here. If you go back and look, which I'll pull that up again in a minute, but if you go back and look at that grade 1, grade 2, grade 3 definition and see the illustrations, is it 1, 2, or 3? As we see above the window, there's a little bit of separation at the top. Those are gaps. It's how you're going to determine, is this a good install, high quality install, or is it not? And as we look at the vaults right above it, there are some fur down strips that are there, which means the depth of that's no longer 5.5. It's thicker than that. So it doesn't really have to be fully filled, but using a probe, which I didn't have one on site with me, using a probe can determine the depth. We'll look at that on some pictures afterwards. But making sure the vaults, all those are covered. You can see some of the darker areas where they came back and resprayed it. Like I said, it was more of an open cell feel to it. I'm not sure if there was some stuff still left in the gun, but as we see, there's a little bit of separation and I don't know if you'd call that delamination, but pull away from the studs. Here I'm verifying that the headers are insulated. You know, that's also for code now. It used to be Energy Star only. Now it's for code. Are they insulated? That one is. It's got an R3 board stuck in it. They're using ladder blocking for Energy Star purposes. So just determining a few times, I put my finger up underneath behind one of those boards and made sure there was foam. I'm not going to tear in and mess up the other areas of that. So checking a few of those just to verify, are they actually foamed behind it? Most of the time when you spray it, it's going to expand anyways. It'll just automatically fill that gap. But looking at this and looking at the wall, I know it was already red tagged. I know this is supposed to be an Energy Star. I know it's going to be grade 1 or required to be grade 1. If I looked at this compared to what I saw earlier, which was this, am I looking at 1, 2, or 3? In my opinion, it's a 2. So, but is the energy model listed as grade 1, grade 2, grade 3? I mean, it depends on what the model is listed as. How was it modeled? Determining that in the field is harder said than done because you may or may not have access to the permit documents when you're on site. Looking at making sure the vaults are done correctly. Again, I see a lot of separation at the stud. Sometimes that could be due to some humidity inside maybe it rained the day before the foam went in. The humidity content or moisture content of the wood may be a little more than what it should be, and it's kind of pulled away because it didn't adhere to that wood. Also with this, if you can tell, just because I've done the inspections before, I can tell the way it's processed. The borate was sprayed first, adding to the moisture in the wood, and then the foam was done afterwards, which is normally how it's done with bats anyways, but that adds moisture content to that. So don't know if it has anything to do with it. It may or may not. Maverick's got a quick question. I may have missed the comment, but how can you tell if it's open or closed cell? It's a great question. Basically pushing on it. If you just push on it or touch it just a little bit, it feels spongy. That's open cell. If it's hard and it's brittle and it starts to crack when you push on it, that's going to be closed cell. But if you know that it's a 2x4 wall, if it's fully filled, it's going to be open cell. They could do no one's going to really do a fully filled 2x4 with closed cell because that's a whole lot more R value than what's required, especially in our climate zones. Maybe up north, but not here. Good question, Maverick. So it's continuing just walking around, identifying the start and stop of the envelope. I can see that they've got ladder blocking there. I can see that behind that T-wall stud, there's actually foam behind it. Looking at the vaults, there are some shallow parts of the vaults. As we see, they've actually asked them to respray it. That's what those darker areas are, as they resprayed it and it came out a different color of the gun. They sprayed it to fully fill it. So I guess at the very beginning, it was not an R19 that was there. And so that's not meeting a grade 1 install for Energy Star. So there's still some looking at just the vaults part of it. Now checking out the wall, there's still a lot of gaps in the front. I say gaps where if you think about when sheetrock gets put up in front of it, it leaves a gap behind it. It's pretty well fully filled. There's some pockets of gaps throughout that entire wall. Most of the vaults are done correctly. Checking and verifying is an R3 board. Is the header insulated? I usually do that with most of the headers. You know, there may be some that are more structural and is not, and maybe it's a solid header and it's not insulated. But the majority of especially Energy Star, the majority of all the headers need to be insulated, making sure it's foamed underneath the seat in the shower. That's missed a lot of times with bats, or even foam as well. Verifying the ladder blocking on the corners. This was just a single story house, so we're pretty much over halfway through the home. It doesn't take much when you're looking at foam because you don't have to look for cutting and splicing around wires, cutting and splicing around piping. I'm just climbing through the wall here. Sorry for the shaking. But looking at that, verifying vaults again. There's some gaps. Whoops. Sorry about that. Yeah. There were some gaps that were there. I sorry, just started it back with this part of it, but I was trying to stop it on the fact that you can see a little bit of gaps between the studs. Again, I don't know if that's pulled away because of the moisture content or there's some shrinking that's going on with that part of it. But that's when you're grading insulation right there to the lower right-hand corner. I mean, you're grading the insulation. You're looking at that 3 categories, grade 1, grade 2, grade 3. How well was this done? If it's Energy Star, it doesn't matter what material is being used. It needs to be determined as a grade 1, depending on what material is used, of course, how the manufacturer determines it's to be installed. And you need to make sure that it hit that installation criteria. Is that they used R3 board on the outside, they're allowed to do a grade 2 on the walls. But with this builder, they did not. So all of this needs to be a grade 1. And this is where we start getting into the area of identifying the envelope and where does it start and where does it stop. Right above me is the service decking for the HVAC system. They've pushed the encapsulated attic in out over the garage. So I'm trying to verify. You see daylight on the upper right-hand corner, but that's daylight because the stairs is pulled down. So if the stairs are pulled down, the light's coming up through there. It's not a missing part of that. They did this pretty well on completing the thermal envelope. There's a hole in the wall right there in the center. That's going to be for the water shutoff valve. So someone's just busted that out. So they're going to actually probably put the water shutoff valve that's there. But this is where it becomes tricky to have to identify starting and stopping of the thermal envelope. As we see, there's a lot more gaps there on the garage wall. Underneath the service deck, we'll look at a picture here in a minute. This is where I have some technical difficulties. It didn't want to straighten out. But that service deck has to be stopped and separated at a certain point. So right above the garage wall is where they've decided to foam that and actually be that the starting and stopping point. That kind of creates a band joist under a service deck, which you normally wouldn't see in a single story home, but it has to be there because they're including that part of the attic as an encapsulation. So foaming the corner, it's a little odd way to do it, but that's, I guess, the best way to do it. There's some, the camera will straighten out in just a second. Sorry, I have to actually hold it the rest of the way. But just, I'm back around to the front. I've verified that they've insulated all the components that were necessary. Now I'm going to head out into the garage and look at that. I'm re-verifying, is the service deck in contact? Is there a separation there? There was. And then looking up here, you see they've tried to create another band joist. On the inside of the house where that 2x10 blocking is, or 2x12, it's not going to be insulated on the inside because of the way that it's being framed. So they insulated it on the inside. And then you see T-ply on the right-hand side being your divider between the attic space and the unconditioned attic over the garage. The subfloor is actually being insulated. I use the subfloor that's under service deck. And technically, it's like what you'd normally see. You're trying to insulate the conditioned side, so having it up against the service deck is the way to do it. So just verifying the envelope. So the envelope extends out over the garage. What also is enclosed in that, and we'll talk about it more in a minute, is the stairs. So the stairs are now part of the conditioned thermal envelope, and the stairs now that have to adhere to the code. And we'll talk about it in a minute and look at some pictures more close up going forward in the future. But the little cubby hole here, the little niche for the water heater, making sure the band joist or the ceiling of that is actually separated. It is. They foamed around the stairs. I'll talk more about the stairs in just a minute, but just verifying, where does the envelope start and stop? Coming up into the attic, as we see, we'll talk more about kind of what we're looking at from a closer perspective and in a photo in a minute. Right now, I'm just verifying, is all of the components insulated, or is the thermal envelope complete? Is there not any gaps or missing insulation? Looking at the certificate from the installer, verifying, but if you look at it, it says that the unvented attic under roof deck is R22 at 6 inches, and the slope ceilings cathedrals are 22 at 6 inches, and then the walls are 13 at 3.5 inches. So we verified that part of it. My question though, if you're using a 2x6 on a vault and you shaved it to fit sheetrock in front of it, that's only 5.5-inch cavity. It's not really adhering to the 22, even though 19 is what we're looking for code, so that's still going to be acceptable. Looking at the divider wall, looking at the roof. We'll talk about this at the very end of the video, but there's no vapor diffusion ports, which can be used in foam. I haven't really seen that being used in Texas. Verifying all of the attic is enclosed. I actually stop it here. I actually tried to open that box and look at the fresh air, but that was I was not able to do that. It was screwed into the side, so we couldn't actually get to that. But this is another short video of just me verifying the starting and stopping of the thermal envelope. Looking at it from the first floor all the way up. Does it continue? Yes. Is there foam? Is there blocking, and as well as insulation all the way around? Yes, there was. Is the service deck out over the garage insulated? Yes, it was. Was there a definite separation from service decking that's uninsulated to service decking that is insulated? Yes, there was. And like I said earlier, we'll talk more about the stairs in just a second. So just looking at that part of it, I put some breaks in it, but that's part of what we're looking at. This is an example of the certificate of compliance. So this is not the same as the one that's required in Chapter 4 under 401.3, which is left at the final, which is usually found on an electrical panel or on the HVAC systems. This is one that should be done at pre-drywall immediately after installation. Let me catch up with some questions here. Let's see, hold on, let me go back. Where would you see the model design of the house that was projected to be followed? It's on the permit documents. When somebody turns in the energy report, it should be listed on the energy report as to what they're looking at and what's being used. If it says R15 and it's foam, that there's no real chance of getting there. As Cody said earlier, there's not the density of the open cell foam to hit 15 in the cavity. So if they're using 15 as compliance and you go on site and it's a 3.5-inch cavity only, and they're not using continuous board, there's no way they're going to get to 15 with foam, not with open cell. And then a side-by-side picture of open cell and closed cell. Yeah, good point, Guadalupe. I could do that in the future. I didn't have a closed cell that we looked at. How do you tell if there are voids behind the foam? That's hard to do, Robert. I appreciate the question. Sometimes you can start seeing some, I don't know, Cody might be able to answer that a little bit better, but having voids behind it, he's talking about if it's delaminated or pulled away, or if an air pocket is behind it. That's very tough to see. You don't want to destroy the foam. You don't want to take out the insulation to look at it. Sometimes it just may look odd, and you take a probe and you try to stick into it and you actually hear a hollow sound that's in it. That's a really hard thing to do, Robert. I appreciate the question. Do manufacturers make a non-flammable spray foam? I don't think so. That's why a lot of times you can use the spray-on covering, or I forget what the name of it is. Cody, you can put it on there in the chat if you want, but it's a lot of times in commercial, if you have any foam insulation exposed in a commercial attic, usually you have to put a flame retardant on it, or a flame barrier that's on it. And so that can be put on there to save that. As per code, there needs to be air attic separation. Absolutely, Norma. That's great. What material can be used to separate the attic? I was going to get to that because I know that was part of that. So in a few minutes, we'll actually next couple of slides, we'll talk about some of that. I appreciate the question, Norma. Let's see. Then FYI, Cody says, FYI, you may want to keep an eye out on the closed cell 2x4 builders, looking great to meet Energy Star requirements without going 2x6. I'm having conversations with builders now. Yeah, so it's still a big question about when people are doing it correctly in the field for spray foam. Does spray foam cause any issues with wiring and PEX? Paul, it's a great question. I don't think so. I mean, the majority of it now is isonine that we see out there. It's a castor oil product. I don't think there has any issues or side effects to wiring or PEX if it's sprayed over or around it. David said, is it required for the contractor to identify the brand, model, and spray foam insulation? If you look at this certificate, they're showing this is from the manufacturer, and they're actually marking on there what material is used. Yes, they should do that. They say he said, I see foam or spray foam written on the certificates a lot. They should be identifying. Yeah, Benjamin, you're right. Ignition barrier, that's what it's called. The only way is to cut out a piece. So I think Cody's addressing the gaps or empty voids behind the insulation. The only way is to cut out a piece and have that you're worried about, to see if the installer and the product, if it was raining that day and there was moisture buildup in the wall cavity, you could have delamination or foam that separates from there. It's a great point. But yeah, on the certificate, as what we're seeing here on the list, or on the webinar here, we're looking at the certificate. It should state what product's being used, because what you're trying to identify is what's the product's R value per inch. So if you look at the certificate of compliance, building thermal envelope for sprayed polyurethane foam, this is what it says in code: insulation and the installed thickness and areas covered, and the R value of the installed thickness shall be indicated on the certificate. Also, the thickness and installed R value of sprayed polyurethane foam shall be indicated on the certificate provided by the installer. Should be left immediately after spray, which is what the next one says. Any installation certificate shall be left immediately after installation by the installer to certify the installed R value of the insulation material. What this is used for is for inspectors or building officials to actually inspect and verify, yes, the product they're using. You won't see a manufacturer's label, but this certificate comes from the manufacturer product that they're using. It tells you its R value per inch. They're telling you the thickness that they've sprayed and what they're actually obtaining. This is not from foam. This is from, this is not from foam. This is from a blow-in wall insulation. So it's 4 inches and it says R15. If you saw that on foam, that's incorrect. Unless they actually have a thicker wall, but they probably would not. Now, Robert says ERS report will tell you. That's it. That's true. Mark says ASB, let's see, gives you so there is other materials out there being used. It's 4.4 R value per inch. That's a great to know, Mark. There's other products that are out there. Manufacturers are catching up and using different methodologies or different materials to actually produce higher R value that's there. Yep. And as Cody says, we just addressed that, but they need to identify it, but not all foams have the same R value per inch. That's why you want to know what manufacturers used or what product from the manufacturer is being used so that you can identify the right R value per inch. It takes a quick Google search just to say, oh, if I'm using X, Y, and Z product, if they're using that, what's its R value per inch? Google will find it. You'll find probably the manufacturer's detailed listed on their website, and you can find out what it is. But looking at that, this is a before picture, before foam is actually installed. So you're looking at separation. This builder's used OSB. They also use a combination of T-ply. So there's a couple of shots here before the installation. The top left, of course, is dividing the encapsulated attic from over the porch. The bottom right is dividing wall over the garage that separates the garage attic. It's a vented garage attic from the enclosed attic over the house itself, which is now incorporating the attic stairs. And as I said earlier, we'll talk more about the attic stairs in a second. A couple more shots of that. Different house. But as you see, most of this it's extending the encapsulated attic over an unconditioned garage. What they're trying to do is keep from having to buy another door on a vertical wall to get you into the attic over the home. They're just going to push out the envelope and actually enclose the stairs into that. This is another shot from at the bottom. Now they're using T-ply as the separator. And Norma, I'll get to that in just a second. But if you notice at the very top, instead of cutting out the gaps between all the rafters and now putting it up next to the roof deck, they've actually just stopped it short. It hits the bottom of the rafters, and then they just foamed all that closed. That's one way to do it. But every time you have a rafter going through that foam, that's areas of leakage that can happen. So just determining, is it sealing very well against that? Is there gaps between all of those rafters is what you need to look for when you're doing your inspections. Another shot of the same thing we talked about earlier, identifying that envelope. Is there gaps and breaks or separations in the envelope? We talked about earlier when we looked at it, this on the right-hand side, that you shouldn't see daylight from there. I shouldn't be able to stand out on the patio, which is where that is, and look up into an encapsulated attic. There needs to be blocking or service decking or whatever needs to be there so that the foam is completed. Same thing with on the left. If I'm standing in the garage and I'm looking up, which is the next photo, you'll see, which we've already seen this one, but we'll see I'm looking from an unconditioned garage up into an encapsulated attic. I shouldn't be able to do that. It should look like what we see on the next one, which is basically closing all of this off, having blocking all the way around, encapsulating that entire attic over the garage, the portion that's part of the encapsulated attic over the house. So verifying foam and floor cavities are challenging as well. But as with most flooring, you have to have, if you look at the upper right of the right photo, normally you'll see blocking that's there. That's required if you're having to insulate. If it's a second floor, this is a service deck in an encapsulated attic. But if it was a second floor with conditioned room above it, you'd see blocking there. But foam creates its own air barrier after 2 inches in depth. So nothing has to block at the end. It's okay with leaving it just like this. So that's a good way that you can, there will be a lot of ways, that's the way a lot of them are doing that. But as you see, it's kind of concaved in the middle of that insulation under the foam, especially the one on the left-hand side. So verifying that with a pointer or depth marker to try to identify, is that the actual depth that's needed for that insulated area? So it's going to be treated the same way as you would as a conditioned floor over an unconditioned space, because that's an encapsulated attic, which is unintentionally conditioned, but it's part of the thermal envelope, which means it needs to adhere to the same R value. And here's the stairs we're going to talk about now. But that stair being part of that envelope now is subject to meeting the thermal envelope requirements of the code. So once this happens and the stairs are part of that, you've got several ways that you can do it. So stairs over the garage is part of the thermal envelope. If it's part of the enclosed encapsulated attic space, there must be separation from conditioned to unconditioned. Now it must meet the code for the R value requirement. Minimum is R10. If the exception is met, you can. And I'll read that. I didn't put that on the slide, but it's in the code book. R402.2.4, attic hatches and doors that states that they need to be having the same R value as the ceiling or wall that they're installed in, unless you meet an exception. For horizontal doors, which is what this is, you need to have, it says all of the following must be met. Average R value must be R10 or greater. This is not. Not less than 75% of the panel must have insulation R value of R13 or greater, which is not. The net area of the frame opening must be 13.5 square feet or less. Or less, which this does. It's a manufactured door. They know what that sizing is. And then it says must be weather stripped, and it's not. So this one is not compliant with the energy code. And then lastly, using that exception cannot be part of a UA alternative pathway trade-off. So if they're doing a res check and they're trying to use that as an alternative trade-off method, you can't just say, well, the door is no longer insulated, or doesn't have to be because we're using that in the trade-off, or you go less of an insulated value. Let me catch up on the questions. Cody said there still is open cell products that will give you R15 and 2x4 that I know of. Okay, there may be, some open cell products that can give you R15. And then where the R value per inch makes a difference is in a 2x6 on the roof deck. Absolutely. So this one is not compliant with code. This door should be removed and replaced with an R10 door. They make those, manufacturers make those. The whole facing of the door is R10, which means the average R value is 10, not less than 75%. Is that, well, it's not going to be 13, but it's acceptable to have that. It used to just be an Energy Star requirement. Now it's a code requirement, and it's part of the envelope, so it must be insulated. So Norma will speak to that now, but talking about backer materials, on divider walls, garage walls, you'll see various materials like T-ply, netting, OSB. I've heard, and Cody can speak to some of this maybe, but I've heard that it's not recommended for house wrap, such as Tyvek. I don't know if it has anything to do with the manufacturer. There's no list really that I've seen from a manufacturer that says this is an approved product or method that can be used. I just know by someone that called Tyvek that they said they didn't recommend it. It could be something to do with the heat that's generated during its application process, or it could just be that Tyvek is choosing not to be responsible for another product's performance. That's more likely the case, is they're not wanting to be part of that product performance. Yeah, Robert, plastic sheathing used a lot. You're in a dry climate, that's probably okay. In the more humid and moist climates that we're in from the right side or the east side of Texas, you'll have condensation buildup, and delamination can happen between that. I've seen plastic used in Dallas when it first started being used, but now I see most of T-ply, netting, or OSB being used. So that's a good point. I mean, if you're in a dry climate, that's probably not an issue. Plus, in our climate, you can't use a vapor barrier. In your climate zone, you can. So you're not worried about that condensation buildup. So ceilings, and part of that, knowing the rafter size is the easiest way to determine the depth. I didn't have a probe to stick in here to look at it, but both of these photos, I know for a fact by looking at the edges of these rafters, they were 2x6s. So it appears to be fully filled at 5.5, and all rafter tops are covered, which is important because you're blocking a thermal bridge or cutting a thermal bridge to not allow heat to enter into the attic. But if you can see the outline of each rafter, that tells you the installer did not go beyond the depths of the cavity. In other words, they filled the cavity and then they covered the rafter tops. So as a result, the achieved R value is about 20.9. So is that acceptable? Well, that depends on the energy model or the energy report and what it's claiming. So I'm not really going to go into full depth of that, but it's unclear. And it's up to the interpretation by each cities, but some cities are requiring ceiling R values of their climate zones to be achieved even when using foam. So if your climate zone requires 38 on the ceiling, they're requiring 38 under roof decks. That's probably not going to happen. Most of the times you'll see foam look just like this. They're trying to achieve an R21 or R22 under roof deck. I do know of one city that did add a column to the prescription table, and it gave a column that says under roof deck. So if you put insulation directly under roof deck, they're allowing that 20, or 22 because they're realizing that you're keeping heat out of the attic to begin with. You're not allowing attics to heat up to a 140 plus degree temperature. You're keeping it 3 degrees different from the inside. So even that lesser insulation is still acceptable, and they're leaving that moving forward. The hard part is getting a modeling software, especially a easy res check or a UA alternative in the res check, to get that to understand that you're less than the required R value of a ceiling in foam. You probably won't get that to pass. So in a plans review, and you're looking at it and you say, well, I see that they've put 38, and you go out there and it's foam and it's only 5.5 to 6 inches deep. They're not achieving what they need to, and because it wouldn't pass the res check. So if your city's of the ladder and you're allowing the 21 to 22, then basically you're looking at R value per inch of 3.6, 3.8. So if the material is installed with an achieved R21 or R22 in the depth of 6 inches, should I actually be able to see the outline of each rafter? Probably not. I'm not saying this is right or this is wrong. I'm just saying this is what I see. This is what I go through. This is the conversations that we have. You see each outline of every rafter, which tells you that you're not beyond, because if you're beyond, it would almost all be smooth and at the same level. So having it that way, I'm going to assume without probing this, it's 5.5 inches deep. If it's 5.5 inches deep, it's 20.9 at its best. So vaults, kind of the same way with that. We talked about it earlier. Now we see a picture on the upper left is a probe that's actually probing the shallow part of the vault itself. Vault should be R19 at a minimum. With that, if you look at it close enough, there's a black piece of tape on that probe. That tape starts at the bottom, starts at 5.5 inches. So that's roughly 5 inches deep in the shallow part. If you take 3.8 multiplied by 5, that's R19. So they're hitting it in that shallow area. It looks wrong, but it's hitting the right R value that's required. So that's where it becomes difficult to look at it and go, are they achieving the correct R value for that component? It's a lot of times it's misleading on the way it looked. It looks wrong to me because if I saw a wall that looked like that, which is the one on the right, at the top right, if I saw a wall that looks like that, that's wrong. If the vault looks like that, it's not wrong unless it's not meeting the R19, if that makes sense. Just to go back a couple of slides, Cody actually put on there that Tyvek will melt. So that's probably true. The plastic that's used for the woven material will not work with the high heat that foam exceeds when it comes out of the gun. So spraying that on Tyvek, it probably will melt in a lot of places. That's, to me, in my opinion, it's not allowing it to be structurally sound because your backing you're using is causing it to just basically melt. On the lower center picture, there's actually a vault here. I have a probe that's there. That's the same picture that we see close up over there. Again, at this distance, it looks wrong. When I got up to it and actually stuck a probe in there, even at its shallowest point was still 19. However, if you look at the certificate and they're putting 21 or 22 there, now it's wrong because the model should reflect what's actually being installed on site. Does it meet code? Yes. But does the model now pass? No, because it's not the R value they said they intended to install. That's where it starts getting confusing and it starts being a judgment call in the field. Will I say this is insulated? Yes. Does it meet code? Yes. Did they use 19 in the model to say that was compliant and it passed the model? No, which means technically what they did here isn't right. But you need to know all of that information while you're on site to make that judgment call. And if you don't have that information, you're just looking at it from a code basic standpoint only and saying it is 19, it meets the requirement, let's move on. However, if I went back to that model and put 19 instead of 22, it will fail more than likely. And once it fails, that means this is not compliant with code. And then the furring strips can be used as well. The top right, it's hard to see. Sorry for that short picture, but if you look, I'll use the pointer just to point this out. Right at the top of these, there are furring strips that come down, which makes these pockets deeper than 5.5 inch because they've furred it down. So me looking at the one on the top right looks similar to the one on the left and the bottom, but it's still correct because it's deeper. It's a deeper pocket. The one on the left and the bottom actually is only 5.5 inches deep. And so you have to look at it from a standpoint of, does that meet code? That's again where all of this becomes confusing in the field on how you verify compliance for foam. And of course, band joists. This is a great way of verifying. You can't really verify the depth of this without probing it. Um, I didn't have a probe on me. I don't carry my equipment anymore. I don't have equipment that's with me for that. But basically just probing that and making sure the depth of that is correct. Looking at it and looking at it from the outside. Most of the time when we got to a house at this stage, the outside was already finished. It was either bricked or it had cornice board or hardy board or something was on the outside. You couldn't see where the blocking started or stopped. So you'd have to probe that to see the difference. This actually is better to meet 2024 code. If you were part of our webinars on the 2024, it has to now be permanently held in place. Foam is actually doing that, where bats would not unless you put something there to permanently hold it in place. And as I said earlier, we saw this in previous photos, but this is a single story. I keep calling it a band joist. It's not really a band joist, but it's a completion of the thermal envelope. And if that means creating a band joist like area, then that's what you're going to do. So the gaps between service decking and, as we see in this photo, top of the garage wall is what they're doing, and they're causing that to be that's the point of separation. So they're going to easily just foam that closed, and now that separates the uninsulated service decking to the insulated service decking over an unconditioned garage. So verifying the it's continuous and complete is extremely important when it comes to foam. Ladder blocking, we talked about that. Advanced framing is being used in this house because of Energy Star. The lower left is a 2-stud corner. The lower right is ladder blocking. The upper center is ladder blocking with foam that goes underneath it. You can see it coming out from the T-wall, 2x6 T-wall that's there. There's foam coming out, so there's not a gap behind it. That would fall into the same line of if I'm looking for gaps in the insulation, if they did C channels, or whatever you call them, the U channel or C channel, or a dead space behind that T-wall can't be insulated, which now reduces the grading of the insulation install, and that's gaps in the thermal envelope. With this, that's Energy Star, advanced framing is required. They're foaming behind ladder blocking. They're foaming behind 2-stud corners. I checked a few of those. I don't want to damage the foam. It doesn't rebound like fiberglass does, but it's all being insulated behind it, and advanced framing is being used for Energy Star. So with walls, I put this on here. It was a pet peeve of mine when foam first started coming out. The term was being thrown around, nominal fill. I just said nominally filled, but nominal fill means that you kind of doing an average. You have low spots, you have high spots. You're averaging the R value depth, or the depth of the insulation to meet the R value requirement. To me, that's cutting corners. What they try to do is lessen the workload on cutting the insulation or shaving it. So be careful of the shallow depths. We saw that earlier, though, on the vaults. There was a shallow depth in the middle, but when it was probed, they were still hitting that R19 at the shallowest point, which was still code acceptable. May not be on the model, but it's code acceptable. In the walls, you see a shallow point. That probe, that orange tape at the bottom starts at 3.5 inches. So the depth of that is roughly 3 inches deep. And if you take 3.8 times 3, you're not getting anything but 11.4. So it's not meeting that 13 in the walls. However, if I took an R13 wall and did it at grade 2, that's equivalent to a 10. If the model states that grade 2 is sufficed and passes and compliant with code, this would be okay. So the builder that I'm looking at and showing pictures of didn't start out as Energy Star. They started out as code only. If we did this as a grade 2 and the house passed, then this is acceptable. They have now moved into Energy Star, which now requires grade 1. This is no longer acceptable for the above code program. So you would see a report, an Energy Star report turned in at time of permit. If it says Energy Star and they're certifying it as Energy Star, then every single component in that house needs to be grade 1, unless they're using continuous insulation on the outside of the exterior wall, then they can go grade 2. but most of everything else has to be a grade 1. So even looking at foam, it would have to be perfect. No shallow spots, no, no shallow, excuse me, no shallow channels, no shallow channels through there. The one on the top is actually a 2x6 wall. However, though, if you look at it from the perspective of if that's what I see a 2x4 wall looking like, that's wrong. I would call that out and ask for corrections to be made. Um, because you see too much of the side of the studs. That's the same thing as if you had a lot of compression in bats. But this is a 2x6 wall, so I know it's 2x6. If I probe that and saw that they're at least achieving a 13 for the most part, we're going to call that good and move on. So that's acceptable. It makes its own air barrier after 2 inches, so it's filled enough to where it's 3.5 inches. You're hitting that 13, but it needs to average that or better. So not knowing the information on the model is one of the hardest parts to pass it in the field when you're doing inspections. So if you don't have access to the model and or the report that was turned in at time of permit, you don't really know what you need to inspect to, is the whole point of that. So this is a quick 2 photo of just an Energy Star home where they're trying to uphold them to grade 1. And so they're looking at the components. All components must meet a grade 1. This house is not using continuous insulation. So all of this red spray paint is markups that need to be filled to achieve a grade 1. I do know and do understand by being out in the field enough to where, as the builders would say, or even the installers, and Cody would probably agree with me, if they now have to get a truck on site to fix all of this, it's a minimum charge of close to $1,000. I mean, anywhere from $500 to $1,000 just to pull up on site. It's costly. I get it. I understand it. But this is where the contractor needs to understand, look, we're going for Energy Star certification, and this is what you're being held up to, is a standard of grade 1 across the board, and show them what that means. If they're just installing foam and they think this is good enough because that's what they do with all the other builders they work with, that doesn't mean that it's right. That doesn't mean that it's acceptable, which in this case, as they see the spray paint, is not acceptable. So they asked them to come back and respray the house in all those pockets. It's hard to do that. It'll now expand beyond that level. Now they're going to have to shave it. It's difficult, but talking to the contractor as a third-party energy inspector, you should have a conversation with the contractor and say, you're not meeting the level of compliance for Energy Star. Same thing with this, still more pictures of shallow filled cavities. We talked about it earlier. I'll keep beating that dead horse, but it's, is it wrong? It depends. What's the achieved R value requirement? What's the model say? If they're asking for grade 1, 13, that's not what this is. Which means anything less than that lowers the R value, which means the model no longer passes. But you need to make that decision and that call in the field. You need to have the right information to look at it and go, I can now make that judgment call, and I can understand when it's not correct. So the same thing with that. If you just visualize, the top left is a 2x8 ceiling. The right picture is 2x6 walls. The left lower pony wall is 2x4. But if you visualize the lower left corner and that pony wall, that's a really good install. It's got some gaps in it, but it's still pretty good. I'd still call it a grade 2 all day long, but it's pretty good. But if you see walls that are 2x4 that look like the photo to the right, that's really wrong. It's probably not going to be to that extreme because that is 2x6. They're only filling it to a 3.5 inch depth. They're meeting that 13 in that cavity. But you get the point. You should not be able to see sides or areas of exposed studs on the inside of those cavities. So just keeping that visual perspective and looking at that and saying, now I kind of know what to look for when it's not right. That's the best way to do it. And of course, it never fails. There's always issues that happen. More times than not, when I did a house, there was holes somewhere made by the electrician, a plumber, a low volt guy. They use a foot saw or a hand saw. That's my perspective of they just punch a hole through it. They either kick a hole or they punch a hole through the wall to run a wire, a pipe, or a duct. So these are all on the garage wall, but most of the times it was in a far back corner of a dark attic. So you're running the blower door, you're getting tons of air leakage. It's not passing the blower door on the ACH that's required. So you'll have to go marching around up in an attic and try to find where this air is coming from. And usually the dark corner of an attic, you've got somebody's taken a foot saw and kicked a hole in it, and then ran wires through it. They didn't tell anybody, they didn't fix it, they didn't put it back. They just figured, well, if that's there and I need through it, I'm just going to bust a hole through it and do it. So I've seen multiple holes varying from sizes of this to the size of an exterior door, where they took a sawzall and they just cut the hole and then just pushed out all the foam. So I've spent countless of hours roaming around attics for blower doors, running around the attic looking for holes. And as Robert said earlier, he may have issues like that in his climate, but it's not as detrimental as it is in the northeast, southeast areas of Texas or the east side of Oklahoma, because the more humidity you have in the area and climate zone you're in, the more this becomes a massive problem with comfort, humidity that can lead to condensation, comfort issues, and God forbid, actually going into mold or mildew areas inside the home. From my understanding and from what I'm talking with other people, there are a lot of litigation lawsuits that are out there now pending with homes that are having to be torn down due to mold and rot of the building. Not all of it has to do with foam. Some of it is stucco and not being sprayed properly and not being done properly on the building. But a lot of it can be contributed to high humidity issues with foam. Done incorrectly and or not verified correctly, having too much humidity pass through there. The lower the insulation, as after 2 inches, the air barrier is created with foam, but if it's open cell, it doesn't slow down vapor. It doesn't slow down moisture vapor passing through there. And then more spots that are less than that 3 inches, you just have the increase in vapor permeability inside that wall. Let me catch up on the questions real quick. Cody says, it has a ton to withstand a minimum of 300 degrees upon contact. Yeah, that's 300 degrees on contact when they're spraying that foam. That's a lot. So that material must be able to adhere to that, and Tyvek apparently does not. Tim says, can spray foam be in contact with furnace vents, plumbing vents, range exhaust ducts, dryer exhaust ducts, bath exhaust ducts? Yes to half of that, and no to some of it. So if you've got any kind of furnace vents that's going to have high heat to it, I would absolutely say no, it should not. It may not ignite, but it will smolder. So in and around and above fireplaces and the flue pipes really should have a metal collar, a squared around transition, and have the foam at least 1 inch to 2 inches away from being in contact with that. Bath fans, kitchen exhaust, things that are just moving air, humidity, smells, there's not a problem with that. It can be sprayed directly up to that. Good question. Where feasible, we utilize a blower door to at thermal bypass inspection. Absolutely. That's a good way to do it, Scott. And if with foam houses, even at a certain point, at a pre-drywall stage, you technically, if all doors and windows are installed, you technically should be able to run a blower door at that time and verify it. The problem becomes, towards as you get closer to the final, trying to get CO, you've got electricians and plumbers and low volt guys and HVAC guys that are punching holes through it to run wire or to run a plumbing pipe or to fix an HVAC duct. And so now you've got holes in the envelope that need to be addressed. And without running a final blower door, you'll never know that. Stephanie says, how do you address when they have a ridge vent and soffit vents installed on open cell foam? That's a great question, Stephanie, and we'll talk about that at the end of this presentation, but I appreciate that. Richard says, if adding foam will eliminate the need for weep holes. No, because the foam should not be adherent and not be part of the drainage plane. There still needs to be a weep hole and drainage plane behind the cladding and or not behind either the Tyvek, which we talked about not using that with foam, the T-ply, the OSB, anything else that's being created to be a backer for the spray foam. Then you've got drainage plane, and then you've got either cladding or brick or stucco or whatever. There still needs to be a drainage behind there. So no, it will not eliminate weep holes. Good question. So other items to consider. I know a lot of times this is not closely looked at, but other items like what type of heating system is within that thermal envelope. Here we see upper left, 90 plus furnace. It's got an input pipe and an output pipe, and they're plastic. On the lower right, you see an 80% furnace that has a metal flue pipe with no incoming pipes for combustion air. We'll talk more about all of that in a minute, but that gets to be a real health and safety concern. The easiest way to tell is if you have metal flue pipe in an encapsulated attic, not a good sign. That's a health and safety concern. And out of all the investigation and lookup and research I did online, it is split down the middle as to whether or not you should allow an 80% furnace in an encapsulated attic or you should not. Some of the manufacturers say, well, as long as you give it enough makeup air, or if the attic is large enough and has enough volume, it won't create a problem. I don't think that's a good rule of thumb to fall behind. For me, it was always, if you have an 80% furnace in the attic and it's an encapsulated attic, it needs to be taken out. We'll talk about more of that in a minute and why. But all other exhausts need to go directly to the outside. Bath fans, kitchen exhausts, dryer exhausts, all of that needs to go directly to the outside. I still see from time to time that bath fans are just stubbed out in the attic and it's an encapsulated attic. Less likely now that you see it. Most people understand it. They don't do that anymore, but that's just putting humidity more where it doesn't belong to have condensation problems. Another thing you won't find in code, but it's worth mentioning, is verifying that ductwork is separated and not in contact with each other. Here we see this very well done. It's hung separating at the very back end in the center of that picture. Some of it's laying over each other. I believe it's far enough away not to be a problem, but the closer you get to the supply plenum, the more problematic this becomes. The outer silver lining of flex duct is radiant barrier. Radiant barrier does a great job of absorbing heat. It doesn't let it go again until it comes in contact with another material. So all that absorbed heat will quickly transfer into a duct. And then when hot meets cold, condensation forms and you start getting dripping ductwork. So raining ductwork, moisture condensation falling off of ductwork near the system because it's so cold and the heat around the ducts are transferring in and making it even a problem with condensation issues. Yep, Cody's an installer with an installer company. He said we will not encapsulate an attic unless it is a closed combustion or a heat pump or electric resistance heater. I'm glad to see that. There's different people out there depending on what your priority is on selling the material or product that you're using. I've heard a lot of different stories, and a lot of people say it's not a problem. I would never pass an inspection to say it's okay. And that even goes if you're a building official and you're having a house that's being retrofitted or an upgrade's being done or a remodel or it's had a fire and they're redoing it and someone's now sold them on encapsulating the attic. If it has an 80% furnace in it or even older, like a 78%, that is a health and safety issue waiting to happen. We'll talk about more about why. So this is a new thing too, is adding supply and return vents in the attic. So you're probably seeing some of that. If you're not, you might. Robert, you may not see it on Amarillo's side because it's a dry climate, but in the humidity side or humid side of Texas, they're trying to keep that condensation point down. So you'll add a supply vent and intentionally condition the attic instead of unintentionally from the holes in the sheetrock in the ceiling. So all of that's okay. Supply can lower the air temperature, reducing condensation issues. Return can remove the humidity, and again, removing the chance of condensation. So you'll see some of that from time to time, and that's okay. And then this I've not seen this be done anywhere in Texas. That might be, but I've not seen it. It looks like a ridge vent, and it is a ridge vent, but there's still an air barrier underneath the ridge vent. It's allowing moisture vapor to diffuse out of these. It's called a vapor diffusion port. And if you read the IRC, a lot of times it asks for this to be installed, but the IECC does not. So it's kind of, again, it goes back to what does the city require on foam encapsulated attics? This is a ridge vent with an air barrier installed underneath it, allowing for vapor to permeate out of the attic. So it allows for the humidity and the moisture that builds up in the attic. It just removes itself and leaves the house itself. The biggest part of that is verifying, is that air barrier still there and is it intact? So down to the important stuff. If you're doing your inspection and you're looking at it, I just put a simplified, just a checklist that's on here. Don't worry about reading it. It was just a picture to show a checklist. But keep in mind, that these recommendations are from a certified energy inspector, and not everything that we talked about can be found in the code book, such as ducts in contact with each other is not a code requirement, but highly recommended to avoid condensation issues. Not using an 80% AFUE furnace. We'll talk more about that. Code requires a fuel burning appliance to have adequate combustion air. But what is considered adequate? Probably all the manufacturers have different requirements and different measures of what's adequate. In Chapter 24 of the IRC, in Section G 2407.5.1, which is the standard method of combustion air requirement, it states that you must have 50 CFM per 1,000 BTUs. So that's when the system's running. If you had for example, a 3-ton system pushing 36,000 BTUs, you need 1,800 CFM every minute as it's running. Or if you play this out and the attic floor of a house is, well, an attic floor space or volume of a 2,700 square foot house with an average 12-foot height gives you approximately 32,000 cubic feet of air used for combustion. So if I use that 1,800 cubic feet per minute example, it'll take less than 20 minutes to use up all of that cubic feet in the encapsulated attic. I know the numbers aren't right. I made all that up, but you get the point. It happens, and it happens really quickly. So two things start to play out when there's an 80% furnace in the attic. First, it uses all the oxygen in that encapsulated attic that it can. Then the only other way to get oxygen is to take carbon dioxide and strip another molecule of oxygen. Once you do that, it becomes carbon monoxide. And while all that, it's trying to not starve for air, it's pulling conditioned air out of the house to continue to try to burn. However, again, it's a health and safety issue. And if you leave that up to a chance, a bad thing can happen in the future, which now means it's really, really a health concern. And some people may not wake up from sleeping all night with the furnace running. So that's why it's not a good idea. I'm glad Cody and other installers are out there that don't do that. And as a rule of thumb, not to do that. If you're a code official and you're looking at a remodel and they're going foam, by all means, it may be a shock to their system and you're telling them they have to replace the unit. Sorry, but it's just going to have to happen because otherwise it's a health and safety issue. They should have asked about that first, or if they pulled a permit for remodel, someone in plan review needs to look at what's currently there and what they're going to. So I appreciate everybody's time. Sorry that this one ran a little bit long. It was a lot of information. I didn't try to rush it too fast. If you ever have any questions about this, please don't hesitate to reach out to me at any time. Always feel free to share my contact information, my phone number, my email address. I'm happy to answer any questions. We've got people like Cody and others that are part of the industry that can help me answer some of these questions. We can read the code book, look at it, decipher it, go through it, look at the intent, and decide then on what the course of action needs to be when you're looking at it. So thanks again to everybody for their time. I appreciate it. And I will see you guys on the next video. I appreciate it.